Does this mean that if I drop a feather and a hammer from a certain height, then they both will reach the ground together? There's a catch. Something called air resistance comes into picture. When you deal with light objects like paper, feather, balloon, etc., the air resistance is going to slow down the light object. Observe the two animations which shows how it behaves when under influence of air and when in vacuum. When dropped in air, the hammer comes faster as there is higher air resistance on the feather. But when they are dropped in a vacuum, they both come down at the same time. Now let us do a calculation on acceleration due to gravity. When a stone of mass m is dropped from a height h, calculate a. the time taken for it to reach the ground, b. the velocity with which it strikes the ground. For free fall, u is equal to 0, which is the initial velocity. A is equal to g, taking downward direction as positive. S is equal to h, that is equal to displacement. Using equation of motion, S is equal to ut plus half at square. Substituting the values, h is equal to 0 plus half gt square. Thus, t square is equal to 2h divided by g, or t is equal to square root of 2h divided by g, which is the time taken. Using equation of motion, v square minus u square is equal to 2as. Substituting the values, v square minus 0 is equal to 2gh. V is equal to square root of 2gh, which is the velocity. Both are independent of mass. Time taken to reach the ground is equal to square root of 2h divided by g. Velocity on reaching the ground is equal to square root of 2gh.